Number solutions, page 12. This is going to be a quick one. It's only got 3 problems on it. First thing we're going to do is we're going to do a calculation in scientific notation and get an answer back in scientific notation. It says to find the arithmetic mean of 2 numbers, x and y. So let's see. The arithmetic mean is if you take the 2 numbers, add them together, and divide by the number of numbers, which is 2. So let's do that. We're going to take 2.5 times 10 to the 6, which is written 2.5 EE 6. And then we're going to multiply that times 3.48 times 10 to the 6. 3.48 EE 6. Okay, and then we're going to, not multiply, we're going to add them. And then we're going to divide by 2. So we get 2.99 times 10 to the 6. 2.99 times 10 to the 6th. One good thing about scientific notation is that it clearly shows how many significant figures there are, right? Because if you would write this out as a number, it would have a bunch of zeros at the end, and you don't know if the zeros are significant or not. But when you write it in scientific notation, if you don't put the zeros at the end, then you know that the zeros are not significant. Give your answer to part A correct to the nearest million. Okay, so to do that, we need to kind of write it out as a real number, just to see, because like maybe you don't know how many zeros there are in a million. So let's change back to normal mode, and then we're going to retype this in, and we're going to see what it looks like in normal mode. It looks like that. So a million, remember, has like 6 digits, okay, and then the millionth digit. So in this case, if we wanted to round to the nearest millionth, then the 2 would be the last number we're going to keep. We can move it up to 3 if we want to, and it looks like we're going to because the next number is a 9. So the 2 is going to round up to a 3, and the rest of the numbers are just going to turn to zeros. So that is part A to the nearest million. Okay? What about number 3? Now we're going to take the 2 variables t and q, and first we're going to write down t as if it was in scientific notation. You see, it's not really in scientific notation because instead of having a number between 1 and 9.99 here, we have 22.05. So let's go back to scientific notation mode, and then we're going to change 22.05 times 10 to the 8th. We're going to 22.05 times 10 to the, times 10 to the 8th. And do you see that it actually moved the decimal point over, and it says instead of 10 to the 8th, now it's 10 to the 9th, right? So let's write that here. It's 22.205 times 10 to the 9th. Okay, and then in B it says to calculate t divided by q. So we could put t divided by q, which is 3.15 to the 6th. That's 7 times 10 squared. 7.5. 7 times 10 squared. Okay. Then it says, write your answer to part B in the form, I already did. Okay, I already wrote my answer in that. Well, what is this in not scientific notation then? I'm going to change it back to normal. And then I'm going to see, okay, what is this in regular form? It's going to be 700. 700. Okay? So here we've written the answer to B in both normal mode and scientific notation mode. Okay, because it asks for it in scientific notation mode here. Okay, last problem. 225 times 10 to the 8th, what are we going to do with it? Well, first we're going to write it in proper scientific notation form. You might think, oh, this is scientific notation, but it's actually not, because 225 is not between 1 and 9.99. So let's go back to scientific notation mode, because we want to print it out in scientific notation. And then we're going to say 225 EE 8. 2.25 times 10 to the 10th. So that is the answer to A. And then the next thing is, it says, state whether the following statement is true. X squared is greater than 10 to the 20th. So let's see if that's true. We'll square it. Oops. Let's try that again. We're going to square it. Man, you know what? My eyes are like really bad. That looks like squared to me. Okay. It should be squared is this one, right? Okay, so it's 5.0625 times 10 to the 20th. Is that bigger than 10 to the 20th? Yeah, because 10 to the 20th is 1 times 10 to the 20th. This is 5.0625 times 10 to the 20th, so it's about 5 times bigger. So, yeah, 5.0625 times 10 to the 20th is definitely bigger than 10 to the 20th. Okay. Now calculate x divided by the square root of x. X divided by the square root of x. Okay, so we'll do x divided by square root of x. And we get 1.5 times 10 to the 5th. 1.5 times 10 to the 5th. What is that, by the way, in normal mode? So we'll just go back to normal mode. It's 15 with 4 zeros. 1, 5, 1, 2, 3, 4, which is also known as 150,000. Okay, so our answer to C1 is 150,000. In C2 it says, hey, give the answer to part 1 in scientific notation form, which would be the first thing we wrote down. Okay, so that's it.